All right. So we want to talk about dividing fractions now. And just like when we were talking about addition and subtraction, we can think of the denominator of fractions just by being some unit, some object. Like 13 apples divided into groups of 4 apples, we know how to do that. You just take your 13 apples, here they are, and you group them into groups of 4 apples. And so we have, our answer is 3 groups with 1 apple left over. So, or if you like, we can say we have 3 1/4. We're using mixed number notation. 3 1/4 groups. This 1 apple left over is a quarter of a group. Okay. Well, if we have 13 fifths divided by 4 fifths, is there anything special about these being fifths? There isn't. I'm going to group them in groups of 4 fifths. So there's my first 4 fifths. There's my second 4 fifths. There's my third 4 fifths group. And I have 1/5 left over. So I have groups of, I have 3 groups of 4 with 1 left over, which is, of course, 3 1/4. But if I wanted to, why couldn't I write this in improper fraction notation? So 3 1/4, well, 3 times 4 is 12, plus 1 is 13 quarters. So 3 fifths divided by 4 fifths is, you can either look at it as 3 remainder 1, or 3 1/4, or 13 quarters. And hey, look at this. 13 fifths divided by 4 fifths is 13/4. So that idea still holds. So in general, if we have A seeths divided by B seeths, up here in this example we had 13 fifths divided by 4 fifths, and we got the answer 13 quarters. So in general down here, there's nothing special about 13, 4, or 5. We're just going to get A over B. Just like up here, as long as our units of the things we're grouping are the same, it's just going to be this number divided by that number. If you remember from when we were talking about what division was in terms of fractions, so remember, A divided by B is the same as A beats. Now we just have some units attached, and the units in this case are seeths. Down here, up here C is 5, so they were fifths. Up here they were apples, but it doesn't matter what they are. Our answer is still going to be A over B. So, in general, we know how to divide fractions that have a common denominator. You just divide the numerators. But we need to be able to divide fractions that have whatever denominators we like. And we all know the rule. So y is A over B divided by C over D. Why is that the same as A over B times the reciprocal, D over C? Why can you multiply by the reciprocal when you divide? Well, let's work it out. It's not too bad, actually. Really, you just have to make sure you get a common denominator. Then we know how to divide. It's just dividing the numerators. So pause the video now and try it yourself. See if you can work out, using this idea here, that if you're dividing fractions with a common denominator, it's just the numerator is divided. See if you can work that out for this, to show that a over b divided by c over d is just a over b times d over c. Okay, let's write it down. So, let's start with a over b divided by c over d. Now, we only know how to divide, or only makes sense for us so far, when we have a common denominator. So let's get a common denominator for both fractions. I'm going to multiply top and bottom of the first guy by d, and top and bottom of the second guy by b. So we get AD over BD divided by BC over BD. And let me tell you why this is true. This is just using the idea of equivalent fractions. Okay. So now that we have fractions with a common denominator, we can divide them. So we know that this is going to be AD over BC. So this is true because we know how to divide fractions with common denominators. So dividing fractions with common denominators. Okay, and that's up here. And that's what we talked about here. Same denominator, just divide your numerators. Okay, but look, if we have AD, A times D, over BC, B times C, we can split this apart into two fractions. So this is the same thing as A over B times D over C. We know how to multiply fractions. Multiply your numerators, A times D. Multiply your denominators, B times C. So these are the same expression. This equals AD over BC. And this is by the definition of multiplying fractions. And there we go. So we've worked out, we started with A over B divided by C over D, and we ended with A over B times D over C. So now, because we're happy with this idea of dividing fractions with a common denominator, we can use that knowledge to divide any two fractions just by multiplying by the reciprocal. And here's the proof that this makes sense. We justified that this rule holds. It doesn't come out of nowhere. So that's really cool. All right, so I want to talk just for a second about the properties of fractions under both addition and multiplication. And the only reason I want to talk just a second about it is because it turns out that we have all of those nice properties that we did with the integers under addition. But now, remember I said that division didn't have these nice properties in the integers because you couldn't divide something like 3 divided by 4. You didn't get an integer. You didn't have closure. But now that we can change all our divisions to multiplications, because we know dividing by a fraction is the same as multiplying by its reciprocal, well, now the idea of division we can kind of, in some sense, get rid of. We only have additions and multiplications. We can change all subtractions to additions and all divisions to multiplication. So, what we have is all nice properties hold. That's great. So we can use all of those nice properties however we like. So let's do something like this. Let's do something along the lines of 3/4 divided by, let's say 12/5 minus a half plus a 1/10. Okay. So, and in fact, let's put another multiplication on the outside of this. Let's do times, I don't know, 2/3. That will do. Okay. So let's try and simplify this then. Well, using our rules for bed mass, we should simplify what's in the bracket here first. And if we remember, well, we can change all of our subtractions to additions of a negative. So this is going to be the same as 12/5 plus negative a half plus a 1/10. And I'm putting in a few extra steps here that than I would if I was just doing the problem, just to show exactly what's happening here. All right. So now we need to add and subtract a bunch of fractions, or I should say, just add, but some of them are negative. Okay. Well, let's just get a common denominator, and that common denominator will be 10. So we have 3/4 divided by, and this is going to be 12/5. Sorry, I might as well do this in one step. I'm going to multiply top and bottom of that first fraction by 2. So this is going to be 24/10 plus -5/10 plus 1/10 times 2/3. So we get 3/4 divided by, this ends up being 24 plus 1 is 25. Remember, I can use the associative and the commutative property because I just have a bunch of additions here. So I'm just going to do it in my head. I am going to move these guys next to each other and group them together. 24 plus 1 is 25/10, and then plus a -5/10, which gives me 20/10. So I can write this, if you like, as 20/10. And then I have times 2/3. But I can simplify this fraction here. This is the same 20/10. If I divide top and bottom by 10, I will get 2/1. So this is 3/4 divided by, I could write it as 2, but I'm going to have it as a fraction right now because I'll take the reciprocal of it in the next step. So 2/1 times 2/3. And just to say what's going on here, I'm dividing top and bottom by 10. Now, remember, I do my multiplications and divisions left to right here. So I have to do this operation before I do this operation. But let me change this to a multiplication. So this is going to be 3/4 times the reciprocal, 1/2, times 2/3. And now what I could do, I could multiply my numerators and multiply my denominators. Of course I could do that. And then cancel out any factors that are in common. But one thing that people like to do is cancel out any common factors before you multiply. It just makes your life a little bit easier. I'll kind of write out what's going on here, but then I'll do it just in one step. So this is the same as 3 times 1 times 2 over 4 times 2 times 3. And I notice I have a common factor of 3, so I'm going to divide top and bottom by 3. And I also notice a common factor of 2, so I might as well divide top and bottom by 2 as well. Or you could say, well, the greatest common divisor of the top and bottom is 6, so I'm going to divide top and bottom by 6. And then you're going to get, well, this is going to be 1, and down here we're going to get 4. But in actuality, the way that it's done mostly is if you have a bunch of multiplications like this, so no other symbol, just a bunch of fractions multiplied, you can just hunt for pairs of factors. So I see a 2 here, 1 in the numerator, 1 in the denominator. I can cancel them out. Or I could say divide top and bottom by 2. 2 divided by 2 is 1. 2 divided by 2 is 1. I see a common factor of 3. 3 divided by 3 is 1. 3 divided by 3 is 1. I hunt around for some more common factors. I don't see any. So I get 1 times 1 times 1 is 1. And 4 times 1 times 1 is 4. So what you're actually doing is this type of thing. But in practice, a lot of people just hunt for factors and cancel out in that multiplication right here. A couple of notes, and this one is just a mistake that I see lots of students make. They'll want to simplify fractions, and they'll see something like this. You'll have a over a plus b, or a and b, or whatever numbers you like, and they'll say, oh, look, I'll cancel out the a's, and I get 1 over b. But that's no good. Remember, you can't really cancel like that. Canceling is kind of a shorthand for dividing top and bottom by a certain number. So if I had something along the lines of this is fine. If I had a over b times a over c, then I could say, all right, I'm going to cancel out my a's and get b over c. Because what I'm really doing when I'm quote-unquote canceling is I'm coming up with an equivalent fraction by dividing top and bottom by that common factor a. Or if you had something along these lines, this is okay. A, B plus A, C over, I don't know, A, D. If you had something like that, well, I notice that these two terms here have a common factor of A, so I can pull that out. So I get A times B plus C, just using the distributive property for multiplication, over A times D. Now, again, what's really happening is you're dividing top and bottom by A. But in practice, in a situation like this, you'd say, oh, I see a common factor, and that's the key word, factor, in the numerator and denominator. So I can just cancel out those A's and get B plus C over D. So just be careful with your simplifications of fractions. Stuff like this is no good. Canceling out through additions or subtractions does not make sense. So make sure that you're not doing that.